Hello, good day. So, this video is all about the Pearson R correlation. By definition, Pearson's correlation coefficient calculates the effect of change in one variable when the other variable changes. So, this video, we will use this test to find out whether child's height and age are correlated. We will find out if as the child's age increases, the child's height also increases and vice versa. So as you can see, this is our data set. We have the x and y variable, child's height for the x variable, and age for the y variable. So we have 50 samples in the data set. So as you can see, we have the equation in computing the Pearson R correlation. We can compute that manually, but in this case, we will use the online calculator for Pearson R correlations to get the correlation of our two given variables, the x and the y variables. So we are now already in a Pearson correlation coefficient calculator. So as you can see, we already pasted the x values of the x variables and the y values for our y variables coming from the given data set. So we have 50 samples, and then after that we will click the calculate R to calculate the Pearson R correlation. So the result for the value of R or Pearson is 0.8437, which means, or meaning to say, this is a strong positive correlation, which means that high x variable scores go with high y variable scores and vice versa. So the computed p-value based on computed r value and sample size n, the r value is 0.8437 and the sample size n is 100. So the significance level is 0.05. The p-value is less than 0.00001, and the result is significant at p is less than 0.05. So to sum up the results, this is our narrative discussion. Our objective: is there a significant correlation between the child's height with their age? Null hypothesis: there is no significant correlation between the child's height with their age. Condition: significance level set to 0.05. Answer number 1. Pearson R is equal to 0.8437. There is a strong positive correlation. Answer number 2. Probability value or p-value is less than 0.00001. If p-value is greater than 0.05, accept the null hypothesis. While if p-value is less than 0.05, reject the null hypothesis. Decision: reject the null hypothesis. Data analysis. The data had been tested with Pearson R correlation to determine the association between height of a child with their age, assuming that the data distribution between the height of a child with their age were normally distributed. The statistical test or the computed R value is 0.8437, which suggests that the height of a child and their age were strongly positive in terms of correlation. Further analysis shows that computed p-value based on the computed r value and sample size is less than 0.00001, which is lower than the significance level 0.05. Therefore, the null hypothesis is rejected.